Hey everyone, thanks for coming to my talk. My name is Joaquim. I'm currently the tech lead, Android tech lead at Twitch. And before that I was at Twitter, working on Android as well. But today I'm not going to talk about my professional work. Today I'm pretty excited to talk about my last personal project, which is a little library, which is unusual for me. It's my first open source library. And in order to understand how I even came up with this idea, I want to tell you a little bit the backstory here. So if any of you know me, I'm a pretty product-oriented engineer. I like UI, UX. I like prototyping. That's one of my favorite things. And I get a ton of app ideas, a lot of them on my personal time. And generally, when I come up with something that I could build as an app, this is basically what goes through my head. I start getting really, really excited. I just have an idea in mind, and I know how to build it. I know I can get it running on my phone. And basically, the next thing I do is run to my computer, and for the next couple hours, this is what I look like. I just have that goal in mind, and I run for it. I go as fast as I can. I just dump my brain into code until I get something that compiles and I can run, and I can play with on my phone for a few days to validate that idea and see if that prototype was worth anything, right? That's all good. The problem with that is after a few days, once you're like, okay, that was good, but I need to iterate a little bit on it, you open up Android Studio again, and my face looks like this. My code is disgusting, of course, because I went so fast. I just wanted to prototype it, right? I did it quick and dirty. It's kind of throwaway. And yeah, it's painful to look at. And so when you want to add something, a new feature to it, it's like discouraging, right? You have to either rewrite the whole thing cleaner so you can add those features, or you have to spend a bunch of time refactoring it. And as I mentioned, I do this on my personal time. Like, time is precious, and it's kind of boring to do refactoring. Well, you already do that serious work all day. You just want to do the fun work, the prototyping work. That's what I like. So I decided I need a change of mindset because I have a bunch of projects sitting on my Android Studio project list that basically are in that state, and I don't want to update because they're really badly written, basically. So I thought to myself, well, what if instead of writing those quick and dirty prototypes, those throwaway codes, I could write these prototypes just as quick, but in a clean way, so that the next time I look at the code, it's actually pleasant to add a new feature to it, and that can maybe, who knows, scale to a real full app, something that I could put on the Play Store. So I know what you're thinking. Quick and clean, generally in software, that doesn't go well together. Generally, you sacrifice one for the other. But with my experience on Android, I've been doing this for a long time, I felt like it should be possible. And so I started thinking about the idea of a framework that would help me build these prototypes just as quickly as I would before, maybe even quicker, but in a way that forces me to write it cleanly. So I started thinking, what would that framework look like? So on the prototyping side, I want something that saves me time, and that means writing less code. It has to be really easy, really approachable, no complex diagrams or like lots of classes, because I'm prototyping. This is my free time. I want to go fast, right? But it still needs to be flexible enough that I can build any idea, any crazy idea I have. And on the other hand, to keep things clean, it should force me, or at least encourage me, to have my code in layers, separate the concerns, decouple my components, mainly so I could reuse them across different screens and maybe across different apps, and make those components composable so that I can start small, but keep building and building and building until I get something more complex and full-fledged. So with those requirements in mind, I kind of put my goggles on and started writing it. And what I came up with is Helium. It's a very lightweight MVP framework that helps you for those quick prototyping, but what you end up with is something that could be a full-grown app if you keep working on it. So the way I like to introduce it, and we're going to look at this in detail, no need to read the code now, but with Helium, what you can do is write a full app in 20 lines of code. And this is it. This is a fully functioning app that you can deploy, and it displays a list of 100 words in a recycler view. 20 lines of code. I felt pretty good when I was able to fit that in one slide. That is basically why I write the framework. No, just kidding. But basically, that's the idea. Less code, layered, clean, and it still works. So let me explain how it works. Helium uses the MVP pattern, but a quite simplified version of it. You still have your 3 layers: data layer, presentation layer, view layer, classic stuff. And for each layer, you have one class that you have to keep in mind. The data layer is actually pretty loose. You can do whatever you want in that aspect, but generally you have a class that's called a repository that gives you your data, right? In the presentation layer, you have a presenter class, and in the view layer, I have something that I call a view delegate, and we're gonna go in it in detail. Now, how do these layers communicate is where it gets interesting. The presenter gets some data from the data layer. That's pretty straightforward. But between the presenter and the view, the way they communicate is via 2 objects: a state and events. These objects are the only thing that connects a presenter and a view delegate, which makes it very, very decoupled. And basically, we're going to come back to this concept of a state and event quite a bunch in this presentation. But what you should remember is that presenter pushes state, and eventually the view will render that state. And on the other hand, the view pushes events, and eventually the presenter will handle those events. So view state and view events are really the core of the framework. View states, as I mentioned, pushed by presenters, rendered by view delegates. They represent your current state of your component, your screen, etc. That can be any object you want. View state is just an empty interface, and I'll give you some advice on how to implement those. On the other side, the events are pushed by view delegates, handled by presenters. These are generally user actions: clicks, scrolls, long press, etc. And again, it can be any object you want, so you're really free there. These objects should be immutable, but it's not enforced by the framework. So let's look at what it looks like in practice. Since we're in Kotlin, and you should be using Kotlin at this stage, I highly recommend you to go with Silk classes for those states and events. It just makes everything really clean, and it's really nice to work with. So a typical state would be something like loading some data from the network, and you can have either no results, an error, or the actual data. So that's like clean and easy to read. And on the other hand, events are clicks, long press. So you can see how I encapsulated it in Silk classes. So it's like really easy to reason through. Now let's see how we use those in presenters. So presenters are where your behavior logic lives. You can break it down into subclasses, but for Helium, presenters is where you know what data to get from the data layer. You know when to get it. And as I mentioned, is where the logic for handling those user actions lives. It's important to remember that. And the framework does for you holding of the state of the presenter. And that's really useful so that you can retain those presenters across, for example, a configuration change, or if you want to change the views and keep the same state. That's handled for you. And the magic happens when you attach that presenter to a view. Now, the data starts flowing between both. The state is pushed to the view, and the view pushes the events up to the presenter. Once it's attached to, the presenter is aware of lifecycle events, and I'll show you an example of that. And the framework automatically cleans up all resources, because when you're trying to go fast and get that prototype up and running, you don't want to think about memory leaks and all that stuff. All that stuff is handled for you. So let's look at the code. When I create a typical presenter, I extend the base class. So this is a base presenter that comes from the framework. And you can see that it's typed with two objects, the state that it's going to push and the events that it's going to receive. So that's my own class that I showed you earlier, that Silk class. And that basically defines the contract of which views are going to be compatible with this presenter. From there, it's pretty straightforward. Here I load some data from a repository. And along the way, I just push state for each step of the loading. I annotated this function with an on-lifecycle event annotation comes from the architecture components. So this is how you get lifecycle-aware methods in your presenter. But you can see there's no on-start or on-stop. It's just this annotation on the methods that you're interested in to be executed on a lifecycle event that you want. And then, so again, here, I don't call any view.show anything. All I do is pushing state. Eventually, the view will handle that. And then, on the other hand, I want to handle those user actions. So I can override a onView event that passes me a event object from the type that I declare up there. And then I can do navigation, I can show dialogues, I can do stuff from here. So let's talk about the view delegate. One of the big differences that I've seen in a lot of the frameworks out there is that basically a lot of those frameworks say that the fragments and the activities are your view layer. You put your view logic in there, your rendering logic in there. I actually really don't like that. I think it's harder to test, it's harder to reuse, it's just not as flexible. I like controlling that class that holds the view, so I can control the constructor entirely, I can have dependencies there, and most importantly, I can reuse them much easier in other places. If I want to move everything from a fragment to now a view, say in a view pager, I'm not tied to that fragment. I just take that view delegate class and put it somewhere else. So the view delegate in the framework, again, there's a base class for it, and it's responsible for inflating and holding the Android view, like layout. It also holds the context, and it's the only class that holds the Android context, and that's really important. And of course, it's responsible for rendering those state updates. And again, once it's attached to the presenter, starts receiving the view state updates, and we'll push those view events up to it. So let's look at a simple example. I create my view delegate. Again, I extend a base class with those two types, the state and the event, the same ones that I had in the presenter. That's how I declare that this view delegate is compatible with that presenter. Then I have a handful of handy constructors to, like, you can pass a ready inflated view or a resource ID, and I will inflate it for you. And then once you're in there, you have access to all the stuff that you're used to, like as you were in a fragment. You can find a view by ID. Here it's like a text view, it says my button. And I attach a click listener to it. And all I do here is just push an event. The event is type click here, and that's all the view does, just pushes an event. Someone else will handle it, the presenter. And then I have to override a render function that gives me the state of the type that I specified. And then for each of those states, I can render the view appropriately. Pretty straightforward so far, right? Now, how do you put it all together? In an activity, for example, it's really simple. You create your presenter, you create your view delegate, completely independent from each other, and then you just call this magic function attach, which will start get the data flowing between both. And that's it. That code in the activity never has to change as you scale the prototype, as you scale the app. This is all you need in your activity or your fragment. And that's why I like that view delegate object, because activities and fragments should be entry points, not where you declare all your view rendering. So I talked about retained presenter functionality, and all you have to change is one line in this snippet. Instead of creating a new instance of the presenter, you go through this static method, which under the hood uses the view model factory from the architecture components. But I like presenter name better than view model. We can talk about it after this, why I don't like the view model name. So I wrap it around this retained presenter class, so it's kind of more straightforward. You don't have to think about it. Okay, so I showed you a bunch of code here. But in the first slide, I showed you an app in 20 lines of code. And that was way more than 20 lines of code, right? So how did I achieve that? And this is where Helium, I think, differentiates each other from other frameworks out there, is that on top of the base core classes, I wrote a bunch of ready-made components for me, principally, to use in my prototypes, but also for anyone who would use the library, for stuff that I kind of do over and over and over again on every app. For example, most apps have some sort of list that loads some data from the network or a database or whatever, loads it and shows it in a recycler view, right? I don't want to have to rewrite that every time I want to do a quick prototype to test a new API. So I made a list presenter that comes with the list view delegate that is all ready to use, and that's how I achieved the app that I showed you in 20 lines of code. I have others for like view pagers. That's also very common in apps. And there's other components that I'll go through after this. So again, these ready-made components is what make this quick prototyping so nice and quick, and allowed me to go even faster when I had an idea, to go from idea to up and running on a phone. And you can actually use them in a more scaled app by composing them into your own presenters. So I want to show you what it looks like in practice. And bear with me here if the demo gods are with me today. I want to write a quick app with you. So yeah, I will. Thank you for reminding me, though. So I just want to show you what's the setup that I have. But basically, this is an empty project. All I added is one frame layout that's going to be the list item, because we're going to show a list in this app, and a little quick helper class for kind of my fake data. So for this demo, I want to write an app that's going to show a list of colors. We're going to have like this kind of rainbow effect. So the first thing that I want to do, generally when I attack a new screen, I want to start by the data layer. So in the data layer, what am I going to need? I'm going to need a model, right? So let's start with a very simple class that's going to be my model. And since I want to display colors, this is what's going to hold the color that's actually going to be displayed. So let's call it color. It's an int. And just to be fancy, I'm going to annotate it's going to be a color res. And that's going to be in my little debug data file. That's where we're going to get it from. Then I want a class that actually is going to be what provides all of the models. So that's going to be my repository, right? So I can create a little class. It's going to be my repo. And this actually is going to extend a base class that comes from the framework that is going to be really useful to use with the ready-made list presenter that we're going to tackle in a minute. So it's going to be a repository that's going to give me a list of my models. And from there, the framework tells me I need to implement something. Implement the getData function. OK, so it wants me to return a list of models using RxJava. Again, just like Kotlin, if you're not familiar with RxJava yet, highly recommend you start getting into it. As you could see in all the talks, somewhere in the framework, we use RxJava under the hood. But if you're not familiar with RxJava, you don't have to use this. You can really easily make your own presenter, as I showed you before. So here, I want to return kind of a fake, say, list of my models that could be coming from an API call. But for this example, I'm just going to generate it. So we can do, let's say, 100 of those models. So I create 100 of my models, and it's gonna need the color, and that comes from like my debug data here. I can just grab a random color and pass the position, and then because getData returns a whole list, I convert into a list here, and I don't want this. Okay, so I have my data layer here, I have my model, I have my repository. The presenter side of it, I'm going to use the pre-made presenter from the library. For the recycler view and all that, I'm going to use the listViewDelegate from the library as well. But I still need to tell it the minimum, which is what does the item look like. So I'm going to skip straight to the view layer. And here I can declare my view item. So let's call it my recycler item. And again, I extend the base class, here base recycler item. And here it wants a bunch of things. It wants to know what type of model it's going to render. So here's type of my model. And then what type of view event this item is going to be able to push. So for now, I don't really know what I'm going to do when I click on one of those things. So I can just pass the interface, the really base class, and that works fine for now. Base recycler item needs a bunch of things. It needs to know the layout of the item, and I created that before. It's just a frame layout with a height. And there's just a line here so you can see. It needs, you can look at the documentation here, but basically it needs an inflator to inflate that layout, and it's going to need a container because we're in a recycler view, and so it needs to know what container to add the item to. And I don't have those right now, so I can just require them in the constructor. So this is the layout inflator, and then a container, it's a view group. Okay, so let's see what the framework asked me to do here. So complete, implement, it wants me to implement a bind method. Okay, that makes sense. It's like the view holder pattern. So it passes me a data of type my model. So here I said that I want to just show the color. So we're just going to set the background on the whole item. Set background color, and I can grab the color. Yeah, context compat, okay, color. I had the context from the view. and the color from the data objects. Okay, so this will set the background color on my cell from the data, okay? So I have my data, I have the view, and that should be everything I need to really think about when I'm doing this. Everything else, if you think about it, is just glue code. So that glue code is always the same thing. We need a presenter. That presenter is going to be a list presenter. And list presenter wants which type of model it's going to show, which is my model, and which view events it's going to handle. For now, as I say, I'm not really sure, so I'm just going to leave it as a view event. And it wants a repository, which is what I created before. So I just create a new instance of my repository. So this internally is going to call that getData function, load it, and push the states, right? Now I need a view delegate. So the view delegate is a list view delegate. And this one is a little bit smarter because all I have to pass it is a layout inflator. And then it wants a recycler item factory, which is basically just a lambda to know how to construct each recycler item every time it needs it. It passes me an inflator and a container. So highly convenient because this is exactly what I need to create that recycler item. So now I can just create that inflator and a container. So this is all I need to create basically a recycler view with its adapter and all the glue code in between. And I just tell him like what my items are going to look like. Okay. Now, these are completely independent until I call presenter.attach the view delegate. Now they're connected. Now they start receiving data and events to and from each other. And the last thing I need to do is actually pass to the activity the root of that view delegate so it actually shows it. Okay, let's try to run this on an emulator. I have it running over here. Oh, Gradle. What do you guys do while Gradle builds? Yeah, right? And then 10 minutes later, after checking Twitter, ooh, I forgot I compiled. I hear the fans running, so I think it's going. All right, and here we are. This is, in just a few lines of code, a recycler view showing colors. And the framework forced me to already have layers, which is pretty nice. Now, let's say I want to do something when I click on those, right? Let's say I want to show a toast. In my dirty prototype work, I would just do, well, yeah, I mean, the item, the recycler item is set on click listener. And here I could do the toast right here. But we're in the Helium framework. We don't really want to do any behavior here because that toast obviously is going to evolve into something else. All I want to do is push an event. What type of event? Well, it's like I click on an item, right? So the framework gives you a click event, which is pretty convenient, and takes a model, the view itself, so it because I'm in a click listener, and the data. So now I can pass a model via this click event to any presenter that's interested. Now, because that's the only event I'm pushing right now, I could type this more strictly to only be click events of my model. So now this recycle view only pushes click events of my model. But if you see here, there's a compile error because now the presenter and the view delegate are incompatible. The presenter says I can handle any view events or specifically just this type of view event, but the view delegate inferred by the recycler item says I only push click events. So in order to change that, I can just say that my list presenter now take click events of my model. And I want to do something when I receive those click events. So because we're starting to customize that presenter, I like to start writing my own class for it. And again, I'm putting all this in the same file, but generally you want one class for each one of these. So I can create a presenter, my presenter. And let's say for now that it's just going to extend this. I could easily use composition here. And instead of extending, like making it a variable in my presenter, but for the sake of the presentation, we're going to keep it simple and just extend. And because I extend, I can just override the onViewEvent function, which now conveniently gives me that click event type. So I know that when this function gets called, that means this event got pushed by the view. So in here is where I would do my logic. So here you can go as complicated as you want, but for now, we're just going to do a simple toast. So what do I need to make this toast? I need the context. The context, I don't have it in this presenter, and I should never hold it, but it comes from the click events. So I can extract it from the view that is passed with the events. So I have the context here. Then I pass my message, so clicked color. And in my little debug data colors, I have a 2-hex string, which still requires me to go through the context compat shenanigans here. And where do I get the actual color from? From the model that got clicked, which is also in the event. Event.data.color. And I need the length of this, short, and of course show it. All right, let's run this. Hopefully it goes a little faster. Okay, it's starting. And now when I click on it, I get my toast. Cool. So now hopefully you can see how this could scale to a more and more complex prototype where I keep customizing my item, I keep having multiple actions here, and my code is nicely layered, and if I come back 2 days later on this, it's not horrible to look at. Now, usually in your data, it wouldn't be something like that quick, right? Because here I'm just generating everything. So if this would come from like a retrofit call, for example, it would take a little while. So let's simulate that with a delay. So I can add a delay of, say, 2 seconds. And let's have a look at how the framework reacts when I add a delay to fetching the data. So we're starting. Now you see a nice little loader. Okay, so I didn't have to add anything. I already have a loader. The list view delegate comes with loaders, empty view, error view by default, and you can customize all those. Now, what's interesting here is what happens when I rotate. You can see that everything gets cleared, and I see that loader again. That means that it's completely throwing everything away and reloading everything. So as I mentioned, we can fix that by retaining the state. And how do we do that? We retain the presenter, because the presenter is the one that has the state. So again, I just changed, instead of creating a new one every time I recreate an activity, which is what happens when you rotate, I get it through this static method here, pass the activity, and pass the type of the presenter that I want to retain. And if I rerun this now, let's see what happens. So first load, I have no data, it loads, it shows the loader. Now let's say I was scrolled down to this red item here, and now I rotate, everything stays exactly where I left it. It didn't reload, it stayed at the position, even though it destroyed the activity, destroyed the view, recreated the view, reattached, but because I had that state retained, when the attach call happened, the view immediately re-rendered the last state that it was in. And now I have, in only a few lines of code, a really clean base for something that could evolve into a much nicer app. So that's it for the demo. Hopefully you got an idea on how to use the library and how it could be nice to write quick prototypes. You can try this right now, today, if you want. It's everything is on GitHub. It's all open source. All you have to do is add it to your Gradle dependency. There's 2 modules right now. The core, which is very minimal dependencies and basically gives you all the base classes. So that's really good for if you have an existing project you don't want to add to. You already have your UI, but you want to test it out on one feature. And then for prototyping and using those ready-made components, I separate those in different modules. So I have a UI module right now, which contains all these list helpers, view pagers, and I want to keep going. Actually, I'm building also this news app completely with this framework, and it's all open source. So it's on the GitHub, and it's also on Google Play. You can try it out. I actually use it quite a bit. It's fast and convenient. And I want to keep adding more and more features to this app as I basically build more of those ready components to make sure they're usable, easy to write, and everything. And for the next steps for this library, I want to basically write more of these components. That's what really I feel makes the power of the library, is that you can basically take Lego bricks together and build an app. So I'm currently working on a navigation module that's going to be separate that will bring you things like drawer layout, bottom navigation, toolbar, tab layout, all this stuff that we use all the time in apps now that's related to navigation. I'm going to make a ready-made component that pushes events and has state so that you can quickly plug it in together in a prototype. And I have more ideas for these components. I could make a camera one, for example. Camera is kind of hard to deal with, and if you want to write a quick prototype that uses camera, you have to set up a lot of boilerplate. So I could make a component for that that's already nice and reactive, ready to plug in. I also like doing little AR core prototypes, so I want to build a AR core one. And I really want a video one, because that's also a little bit of setup. And you can even go outside of UI lens. You could think of data layer components that could be useful. Like, say, if I combine retrofit and room in one component, that would give you networking and caching in a kind of easier to handle way, so you don't have to redo this setup on every prototype or app that you create. So those are a few ideas that I have, but of course, that's the beauty of open source, is that it's open. If you have ideas, if you want to contribute, you can put a pull request, and I'll be happy to code review it and integrate it into the code so that we can all share these beautiful components. So that's it for me. I hope you enjoyed this presentation. Thank you very much, and we have 5 minutes for questions. Any question? Yes, what's up? Yeah, that's a good question. How do I own the transitions? So right now, these components are basically like in-screen components, but you could easily think of kind of a englobing presenter and view delegate that handles transitioning between 2 components like that, basically 2 view delegates. I haven't built that yet, but that's a great idea. Right now, you have to handle your transitions yourself. Yeah. Yeah, so the question is, do I have any intentions to make it platform agnostic? I haven't thought of it. I'm like an Android hardcore guy, you know it. But that's an interesting concept. I think the core actually could be shared, a little bit like Uber showed their ribs ideology that's kind of shared for both platforms. That's a good idea. Yeah, thanks. Any other question? Yeah. Yeah, so the question is, can you have more than one per activity? Is that your question? Yeah, more than one component per activity. Yeah, absolutely. Actually, if you look at the demo app, the news app, it's a bunch of presenters englobed in a master presenter, basically. So the way it works is you would have a main presenter, for example, that would contain, say, a toolbar presenter and a list presenter and a bottom navigation presenter, and they might want to talk to each other. And the framework provides with methods also to expose the state from another. So a presenter could subscribe to the state of another presenter, and that's how you combine and compose. Yeah. Oh, one last. Oh, interesting. The question is, have I used Flutter, and is that an inspiration for it? I actually never used Flutter. I've heard a bunch of talks about it. So it wasn't at all, but yeah, I mean, it seems like the philosophy seems to be the same in a lot of those frameworks. If you heard the talk on Mavericks from Airbnb, there's similarities there too. We seem to be all converging on that kind of model where we can like react to some events, and that way it's really easy to manipulate those states. No, I haven't been inspired by Flutter at all. Yeah. 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 Yeah, so the question is, how do you deal with like ever-growing screens and scoping between those sub-presenters? So the way I envision it, at least, and in the news app, you can already see a little bit of that, is again that kind of hierarchy of having like your big screen presenters composed to sub-presenters, and each sub-presenter could be composed to another set of sub-presenters, sort of kind of a tree like that. And because they're all like objects within a bigger presenter, that's the scope, basically. So a sub-presenter could never live outside of that bigger main presenter, because generally you would retain the outer one, the big main presenter, so that retains all the sub ones, but you would never retain one sub-presenter inside without retaining the big one, if that's the question. So I think this system works, basically keeping that hierarchy, and it should be like almost infinitely composable. All right, last one. Yeah. 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 So the question is, how do you deal with having like multiple events or click listeners from one view? Is that right? So from the example, like the live coding demo I did, right now I was just clicking on the parent of everything, right? But I could easily have like a text view, an image view, a button, and install 3 click listeners separate on each one of them, and push 3 different events. So now instead of a simple click event, it would be like profile picture clicked, text clicked, button clicked, right? And so in my presenter, I receive those events, and now I can do a very clean when profile clicked, open profile. When text click, open detail. When button click, perform like or whatever. And that's very clean and separated, and basically like bubbles down to get individual action. All right, I'm gonna cut it down now. Thank you again for listening. Enjoy the rest of DroidCon.